If you're a year 13 A-level maths student, you probably have seen the chain rule by now, but if you have not, save this video for later, you're going to need it. In this video, I'm just going to go through the basics of the chain rule. I actually do have a free revision guide in the link in my bio on the chain rule. You can access that just by signing up to the link in my bio, but let's go through an example of where you could use the chain rule. So let's say you've got this curve here, and we want to find dy by dx. Now notice how we can't expand the brackets with this curve. It's not like that power there's 2. That power there is minus 9 over 2. We can't really expand the brackets unless we do a binomial expansion, but that's not really going to give us an accurate answer. The trick is to pretend that that thing in the brackets is another letter. Let's say capital X. I've called it capital X. Let's just pretend it's capital X, that thing in the brackets. Now what we can do is we can try and differentiate that with respect to capital X. So just using first year methods, right? Bring the power to the front, take away 1 from the power, and then simplify. So actually what we get when we plug in this x minus 3x squared back into the capital X, we get a final answer of minus 9 over 2, and then the thing that we use is x, and then to a power of minus 11 over 2. Now notice that this is not dy by dx, this is dy by d capital X. So this is not quite what we want. So the trick to go from this dy by d capital X to what we want is to think about fractions, right? Hopefully you can see why this calculation works, right? Because the 3 and the 3 cancel out, right? Basic fractions, same idea here, right? So what you can kind of do is form an equation where the dx is the d capital X's cancel out, right? This is literally what the chain rule is. This is literally the chain rule. So what you can say then is, okay, let's calculate d capital X by d lowercase x. So differentiate that x, take away 3x squared that we called capital X. Differentiate that. That's going to be our d capital X by dx, which is 1 minus 6x. And then using this chain rule formula that we just came up with, dy by dx is dy by d capital X times by d capital X by dx, right? So the previous thing we worked out back here that I'm underlining here, right, that was our dy by d capital X, and then this d capital X by dx we just worked out, times them together, and that's our final answer, right? So that is an example of how you could use the chain rule. So the key conclusion is that if you want to differentiate a function to the power, then any power, any function, the rule is this: bring the power to the front, take away 1 from the power, and then you multiply by the derivative of that function inside the brackets, right? Exactly as we did. Now see if you can try these examples yourself here, differentiating sine to the power of 10 and differentiating ln to the power of a half using this formula, which always works with the chain rule. There are more chain rule examples. I will cover those in future videos, so do stay tuned. This is just the basics.